All right, guys, we are going to go on to the last section of chapter 9. It's on two dependent samples or a matched pair. So the last section was actually the same thing, except it was independent. So if it was independent, we used, well, it depended if we knew sigma or if we didn't know sigma, but now we're going to talk about dependent. Okay, so it says, suppose we wanted to test the effectiveness of the Kaplan SAT prep course. It would be better to use before and after scores from a single group of students who took the course than to scores from one group of students who didn't take Kaplan and another group who took the course. The advantage of matched pair is that we reduce extraneous variation. Okay, so what this means, it means that we take away variability because we're looking at the same group of people, which could occur with two different independent samples. This strategy for designing an experiment can be generalized by the following design principle. When designing an experiment, okay, or planning an observational study, using dependent samples with matched pairs is generally better than using two independent samples. Okay, and that's if you want to, like, again, compare like SAT, if this course is actually useful or not. If you're looking at like husband and wife, maybe you're looking at like their heights, like from the last section, and then so on. Okay, so inferences about the difference from matched pairs. Okay, so some notation for dependent samples are D, and so we're going to be using the variable D, which stands for difference. And what does difference mean? Difference means subtraction between two variables. So difference between two variables. Okay. What is mu of D? Well, what is mu? Mu is the mean, and what does D stand for? Mean is the difference. So it's the mean value of the differences in a population. So mean value of the differences in a population. Okay. Moving on, we have D bar. And if you want to think about it, this is kind of like X bar. And what does X stand for? X bar is the mean of a sample. And so same thing for here. It's the mean differences in a sample. Okay, and then we have S sub D, which is going to be the standard deviation of differences in a sample. And the last one, which I'm kind of running out of space for, we're going to write sigma of D, which is the standard deviation of differences in a population, because it's sigma. Okay, so some requirements, same thing as before. The first one is SRS, and then the second one is going to be, this time they are dependent. Okay, and if they're dependent, they're matched pair, and we're going to be doing a couple examples with that. And the third one is like the three criterias once again. It is going to be, it says normally distributed, or n is greater or equal to 30, or you draw a box plot. And then you say no strong skewness and no outliers. Okay, so same thing as before. Your test statistic, we're going to be using mu of D equals 0. Now, if you're looking at this, that means that's actually only one variable. Even though we're looking at two samples, we're actually going to be combining them. And we do a couple of examples of that. So if I don't know sigma, what kind of test we're going to be using? We're going to use a t-test. So our formula for t is usually x bar minus your mean, but it's not going to be x bar anymore. It's going to be d bar minus your mean of d over, and then your standard deviation of d over the square root of n. And your degrees of freedom is the same, n minus 1. Okay, if you're doing this, oh, and then you're going to use TCDF to find your value. Okay, this is by hand. If you're doing this by calculator, okay, if you're using this by calculator, you're going to use a t-test with the difference. So with the difference Okay, and then you just make sure you write out everything. Okay, so same thing as before. Okay, confidence interval. So this is if you want to find your p-value. This is going to be to find your confidence interval, and I have a little blank here because it's going to be ho is going to be your mu of d equals 0 again. So your confidence interval is d bar plus or minus your e. Okay, your e is going to be t of alpha over 2 times the standard deviation over the square root of n. So like you've seen this before, except we didn't use s of d, we just used s over the square root of n, but this time we're using sd because we're only looking at the differences. Okay, so let's go ahead and write out the steps, and then we're gonna do, I did a lot of examples for this, so I think I threw in like 3 or 4 examples because I feel like that helps a lot with these kind of problems. Okay, so here are the steps. So for the first one, there are a couple of steps. So it's the state, plan, do, conclude. So you're going to state what mu of d is and ho, ha. Okay, really simple. Step 2 is you're going to plan, which is check 3 requirements. State, plan. Now before you do the do, okay, well you can make this in the do part. You can do it by calculator, by hand, but before you do the do, the first thing you want to do is find d bar and s sub d using one variable stats. And this is if you're doing it by hand. And again, I'm going to be doing it by hand and by calculator, so you can kind of get the idea. But you're going to use a 1 var stats, which is in your calculator, or 1 variable stats. This is if you're doing it by hand. Okay, but if you're doing it the do, you first do it like by hand, and then you'll use formula. Then use T formula, which is on the front, and then TCDF. Okay, if you're doing this by calculator, you actually don't have to do any of this. All you have to do is write test and info. Okay, you actually don't have to find d bar and s sub d. It'll do it for you, which is great. Okay, and then the fourth and final step is your conclude. And either way, you are going to go ahead and write your sentence. So write sentences, sentence. Sometimes it's 2, so there you go. All right, so let's go ahead and do an example. So it says, here we consider one aspect of how we treat men and women differently based on their ages. On data set 14 on Oscar winner age in Appendix B, lists ages of actresses when they won the Oscars in the category of Best Actress, along with the ages of actors when they won the Oscars in the category of Best Actor. The ages are matched according to the year of the words were represented. So the table below includes a small random selection of the available data so that we can better illustrate the procedures of this section. Use the sample data below with the 0.05 significance level to test the claim that for the age of best actors and actresses, the differences has a mean less than 0. Okay, so this is going to help us with our ha. All right, so you have this right here. So I'm going to, again, explain it by calculator and by hand. And you are going to need your list. So we're going to call our actresses in L1. And then we're going to look at the actors in L2. And I'm going to show you guys a really cool thing, but this is going to be L1 minus L2. And I remember doing this with you guys at the beginning when we were in class together, but you don't actually have to type this out. It'll actually type it out for you. Okay, so let's go ahead and do our state, plan, do, and conclude. Okay, so our state, I'm going to write a little smaller. So our state is going to be mu of d equals mean differences of age of actresses minus actors who won Oscars the same year. Okay, so I'm trying to describe it. The mean D stands for difference, and I'm only actually looking at this part right here. I actually don't care about the beginning part. I only care about this one right here. Okay, our ho, well, remember our ho is always the same, so mu of d is 0. And our ha, here's where we have to think about it, okay? So it says the differences has a mean less than 0. What is that indicating? That's indicating that best actresses are genuinely younger than best actors. Okay, so what's my ha going to be? Well, is it going to be less than or greater than 0? Okay, well, if it is actresses minus actors, and we're saying that this number is smaller than this number, so like, for example, if this was 1 and this was 3, 1 minus 3, is that a negative number or a positive number? That's going to be a negative number. So I'm just going to write like a little like negative actresses are younger. Like I'm trying to write out like why is it less than 0. Okay, so that's our state. Let's go ahead and do our plan part. So first of all, it did say random selection, so I'm going to say SRS, check. Okay, this time we're checking if they're dependent, so they are dependent. I'm just going to write same year, something really quick. Okay, and then the last one, it didn't say it's normally distributed. It didn't say n was less or greater than, like n is 1, 2, 3, 4, 5. So I'm going to write n equals 5, so need to graph. Okay, so I'm going to go ahead and I'm going to show you guys the cool way to enter in this information. So I'm going to go to stat, edit, to clear these lists out. Sorry. All right, and I'm going to type in my list 1. So I'm going to do 28, 28, 31, 29, and 35. And then I'm going to do 62, 37, 36, 38, and 29. Okay, now I don't actually have to type in the differences. Remember, if you highlight your list, you can type in second 1, which gets you L1, minus second 2, which gets you L2, and if you subtract that, those numbers actually appear. And the reason why I say that is because you're actually not given these numbers. You would have to calculate it yourself. And so there you go. You have those numbers, okay? So what we want to graph is we want to graph the third line. We don't want to graph the first two because that's actors and actresses. So when we do our stat plot, I have to turn this one off, sorry. When we do our stat plot, we're going to do a box plot, but we're not going to do L1. We want L3. So I'm going to hit second 3 and make it L3, and I'm going to go ahead and hit zoom 9. And I'm going to graph it. Okay, so if you look at it, it's actually not strong skewness, and it looks approximately normal. It's like there's no outliers. So I'm going to graph that. I'm just going to sketch it real quick. Something like that. And I'm going to say no strong skewness or outliers. So we're good. All conditions are met. Okay, so I'm going to make it a little bit prettier. So I'm going to go ahead and like mark them like this. All right, so let's go ahead and we're going to do this by hand real quick. And then we're going to do this by, by calculator. And then we'll write our conclusion. So our do part by hand. So if we're doing this by hand, you actually have to tell me what your mean difference is, and you have to tell me what the, you have to tell me what D bar is, and you have to tell me what S sub D is. Okay, and how do you do this? You find this using your 1 var stat for L3. Okay, so when you're doing something like this, you're gonna go to stat, you're going to go to calculate, and you're going to do 1 var stat, and you want to change this to L3 if it's not L3, because we only care about the difference. We don't really care about the beginning part. We only care about the difference. And so your X bar, which is your D bar, is negative 10.2, and your S sub X, which is really your S sub D, is 14.653. And there you go. You have all your info you need, and now we can go ahead and do the math. All right, so let's go ahead. By hand, this is a t-test. So I'm going to go ahead and write the formula out again. It's going to be D bar minus your mu of D over your standard deviation of D over the square root of n. Okay, so my D bar is negative 10.2. My mean is 0 because that's what I wrote as my HO, over my S sub D, which is 14.653, over the square root of n, and n is actually 1, 2, 3, 4, 5. Okay? And so I'm going to go ahead and calculate this out, and I'm going to calculate this out, and I'm going to find out what variable that is. Okay, so negative 10.2, I don't have to write minus 0, divided by 14.653, divided by the square root of 5. And I should actually put this in parentheses real quick. Okay, so I get negative 1.557. Okay, and that's your t-value, but I want to find my p-value with that. And if you think about it, this is less than, so this is a right, it's a left tail test, I'm sorry. So we're going to go ahead and do TCDF of negative 1,000 and negative 1.557. And our degrees of freedom is actually going to be 4. So this is our lower, our upper, and our degrees of freedom. And we're going to go ahead and calculate that, and I'm going to get TCDF, negative 1,000, negative 1.557, and 4. And I get my p-value to be 0.907. Okay, and there we go. All right, so this is by hand. Let's go ahead and do it by calc. So think about it like this. It's actually only one variable we're looking at. We're only looking at the difference. So if you think about it, we're not looking at two proposition or two variables. We're only looking at one variable. So if we're doing this by calculator, all we're doing is a t-test. Okay, it's just a normal t-test with just 5 numbers of data. So I'm going to do second stat test, t-test. Now here's the thing you can do. You can either input your data with your stats, okay, or you can go to data and you can click L3. So I'm going to do L3 because I've already have the data in it. So I'm just going to write data. My mu sub 0 is 0 because that's what our host says. My list is in L3, so I'm going to write L3 real quick. My frequency, I don't have to write that as 1. My mu is going to be less than mu sub 0, so I'm going to write mu less than. I'm going to hit calculate. And ideally, you should get around the same answer. It's not going to be completely exact, but this is negative 1.557. And our p-value is going to be, pretty much the same, 0.097, which again is the same thing. Okay, so if you're doing it by calculator and by hand, it works out the same answer. Okay, our last part is our conclude. Okay, so we're going to write p-value is equal to 0.097. which is greater than or less than alpha. It is actually greater than alpha. Okay, so what are we going to do? We are going to, fail to reject Ho. There is no sufficient evidence that there is a mean difference of ages of actresses and actors who won the Oscars. Something like that. Okay, there you go. All right. Let's go on to the next example. All right, I have a couple more. I think I have 3 more examples, and that's the end of these notes. All right, so this one says, here's some data. Practice creating a 99% confidence interval that you were given. This is randomly sampled data, and the significance level is 0.05. Okay, I'm not going to actually go through every single step for this. I'm kind of just going to talk about this just because I do want you guys to see how to do this. So this is a 99% confidence interval. Okay, the next thing you want to do is you want to observe what you were given. So you're given N1, X1 bar, X2 bar. Okay, great. And then this time you're given sigma. So if you're given sigma, is it a z-test or a t-test? Okay, so if you're given sigma, it is it's a z-test. Okay, and that's not like the test you would type in, but you have your, it's a z-score. Let's go ahead and write it like this. And your z-score, if you know it, is 2.576 or 575. I use 576 because it rounds out to that. Okay, so that's our z-score formula. So I'm going to again do this by hand, and I'm going to go ahead and do this by calculator. But before we do that, I'm going to kind of extend this out. So if you were asked to do this on your own, it wouldn't be like I'm just adding extra stuff to this. All you have to do is find the confidence interval and then write out your sentence that you've done before. I'm gonna kind of do a little bit more just because I do want you guys to see how your ho and your ha can be playing into this. Okay, so I really don't know what the problem is. It just kind of gave me some data. So I'm gonna assume that my ho is mu1 equals mu2. Now notice I didn't write like the difference. How do I know it's not the difference? Well, usually differences, you have to have all the data. Because if I just had N1 and N2 and I have the two means, I can't find the mean of each, or like each difference and then find the mean of that. It's not possible. So my ho is going to be that, and then my ha is going to be mu1 does not equal mu2. And we're not really going to use much of it. We're just going to go ahead and talk about this. But let's go ahead and find our confidence interval. So this is our, well, using z-score, our formula is going to be x1 bar minus x2 bar plus or minus your e. Okay, and if you remember, your e formula is your z alpha over 2 because we have sigma. If we didn't, it would be t, okay, times the square root of sigma 1 squared over n1 plus sigma 2 squared over n2. Okay, so we're going to go ahead and calculate this by hand and by calculator, and then we're going to go ahead and write our sentence. Okay, so by hand, we have, I'm going to just calculate E real quick. So E equals, and I'm not going to write out the formula because it's right here. I'm just going to do 2.576 times the square root of sigma 1, which was 6.5 squared, over n1, which was 50, plus 7.8 squared over 40. And that gets you your E value. So let's go ahead and calculate that real quick. So I'm going to clear this out, do 2.576 times the square root of, parentheses, 6.5 squared divided by 50 plus 7.8 squared divided by 40. And I'm going to just round this to, whatchamacall, 3 decimal places. So I get 3.962. Okay, so my last step is to actually do, like, find my confidence interval. So it's x1 bar, so 84 minus 80. And I'm going to add and subtract 3.962. And I'm going to go ahead and find my confidence interval. So I'm going to do 84 minus 80 minus 3.962. I'm going to go ahead and highlight this and just change this to a plus. So I kind of just make it quicker. So I have 0.038 and 7.962. And this is my confidence interval. Okay, and this is if you're doing it by hand. If you're doing this by calculator, what are you going to be using? For a calculator, you're going to use a 2-sample z interval. Okay. Okay, so if I'm using a 2-sample z interval, I'm going to go ahead and figure out what I need to type in. So stat tests 2-sample z interval. This time it's not data, it's actually stats because you actually have to plug everything in. So our sigma 1 is 6.5, our sigma 2 is 7.8, our n1, sorry, our x1, that's what it asks for first, our x1 is going to be 84. Our n1, sorry, I should be looking at this, is 50. Our x2 bar should be 80. And our n2 is 40. And our confidence level is 0.95 or 0.99. So it was right. I'm going to hit calculate, and I'm going to go ahead and write the info out. So 0.038 and 7.962. So actually very like the same answers. I don't have to write this values out because I already wrote it out here. Okay, so this right here, you're actually getting the same answer. And again, it'll be a little bit more or less the same as long as you're close enough. Okay, so we're gonna go ahead and write our sentence. So we are 99% confident that the interval from 0.038 to 7.962 contains the true mean, of the data. Like, I don't really have the problem, so I'm just gonna write the data. Here's my question to you, okay? Is 0 in here? Is 0 contained in here? Well, if you're looking at a number line, 0 would actually be like over here, okay? Because it's not in between. So if 0 is not in between it, which one of these are we looking at? Since 0 is not inside this interval, it's not, like, they're not equal to each other. They're not, like, it's this one right here. So it just a little, like, heads up, since, and I'm not asking you to do this, but it's just a little interpretation. So 0, since 0 is not in the interval, we would reject Ho and say there is sufficient evidence that the means are not equal, okay? Just a little extra added to that. Okay, so let's try the next example. Again, if you want to pause it and try it out yourself, you can. If you want to go through it together, we can. Up to you. So it says, using the same example, sample from example 1. Okay, so the first example, construct a 90% confidence interval to estimate mu of D, which is the mean of age differences of the Academy Awards actors and actresses, by using a confidence level of 90%. We get a result. We can get a result for the hypothesis test in example 1. So we're actually going to get the same one. Because the hypothesis test is one-tailed with a significance level of alpha equals 0.05, the confidence level should be 90%. Cool. So I actually don't have to do all the checks. So state, I don't actually have to do everything because it's from the example 1, but I'm just going to go ahead and write the mean difference. So your Ho was mean difference was 0. And my Ha was that the mean difference is less than 0. Just so we have the idea, but we don't have to rewrite this part. The plan part, I don't have to because it's the same example from 1. Let's go ahead and do the do part. So again, I'm going to do this by hand and by calculator. It just makes your life a lot easier. So if you're doing this by hand, you first have to find your confidence. You have to find your T value. So remember, T of alpha over 2, you have to know what your I guess what your value is. So the way you do this is for 90%, you're going to use inverse T. And so if there's 90%, that means there's 10% left over. That means there's 5% in each tail. So your area is 0.05 and your degrees of freedom is 4. So I'm gonna write this as area and degrees of freedom. And I'm gonna go ahead and do this. Remember, there's no secret, there's no shortcut to this. So 0.05 and 4. Z scores are the same throughout, but when it's T values, you kind of have to do this. So it's 2.132. Okay. All right. The next part we're going to go do is we're going to use our formula. So this is going to be X bar. So our confidence interval is X bar plus or minus your E. Okay. So let's go ahead and write out what these values are. So our X bar, if you remember from the front page, is negative 10.2. Plus or minus your E. And so you remember E is going to be your T of alpha over 2. So I guess I should write out the E formula. I'll do it over here. So E equals T of alpha over 2 times S over the square root of N. So S sub D over the square root of N. So you found the square root of S sub D. So we're going to write this as 2.132 times, and then our S sub D was 14.653. And I just got that from the first page. And my square root of N was 5, so we're just going to write 5. I'm going to go ahead and see what I get. So I'm going to just find out what my E value is real quick because I thought that would be easier. So 2.132 times 14.653 divided by the square root of 5. Okay, so I have negative 10.2 plus or minus 13.971. Okay, so I'm going to do negative 10.2 minus 13.971, and then I'm going to do the same thing. I'm just going to change this to a plus. Okay, so I'm going to have my lower to be negative 24.173 and my upper to be 3.773. Okay, and that is my answer by hand. By calculator, okay, we're going to be going ahead and we're going to use a T interval. Okay, so I'm going to go ahead and find stat tests. I'm going to look for T interval. Okay, and this time, again, we're looking at stats. So what was our mean? Our mean was negative 10.2. Our standard deviation is going to be 14.653. our N was 5, and our confidence level is 90, so 0.90. Okay, and I'm going to go ahead and write that value down. So I got negative 24.17 and 3.77, which is actually close. I don't have to write X bar because I did that. S sub X I did that. 5 I did that. Cool. So there we go. I got actually very close to the answers. Now I know this only rounds it to 2 decimals. That's okay. All right, so we're going to go ahead and write a sentence. We are 90% confident that the interval from, and it depends what you have. I'm just going 24.173 to 3.773 contains the true mean difference, of actresses and actors who won Oscars the same year. Okay, now here's my question to you. Is 0 contained in here, in both of these? And if you think about it, it's yes, because it goes from negative to positive. So that means that 0 has to be somewhere in there. It doesn't have to be straight in the center, it just has to be somewhere in the middle. Okay, so I'm going to say, since it contains 0, that means that if it contains 0, we're actually going to look at the hoe. So we're going to fail to reject hoe. There is no sufficient evidence, and I'm not going to write it all out because this is actually the same as example 1. Okay, like if you read example 1 sentence, we actually wrote out the sentence, but the reason is different. The reason we didn't find p-value for intervals, all we did was find the interval, and since it contains 0, you fail to reject. If it doesn't contain 0, then we reject. It's like the same reason or the thing. All right, trying the last example. All right, so again, I would pause the video and have you guys try it out. I am not going to do all of it. I'm just going to kind of give you the gist of everything because I don't want to like type everything up once again. I did this answer key before. So it says, use the following measured amounts of carbon monoxide in Los Angeles and San Francisco. Note that the corresponding entries from the same day, so they are matched. Okay, so it even tells you what they are. For example, the level, level 1 of 4.14 ppm in LA was measured on the same day as the level of 0.53 in San Francisco. So these are all related to each other. Okay. For the population of differences, use a significance level of 0.05 to test the claim that the differences has a mean equal to 0. Okay, so here's a couple of things. First of all, it says it's matched. The population differences, that means you have to find mu of D. Okay, so you have to find mu of D, and it says that the mean is equal to 0. Okay, so we're gonna go ahead and have to figure out what that means. All right, so here's our monoxide. So here's the thing, you're gonna type this in L1 and you're gonna type this in L2. Okay, and then you're going to use L3 and you're gonna type in L1 minus L2. Notice I didn't give you the differences. So if you actually type up L1 and type up all of L2 and then L3, you do L1 minus L2, just like the first example, it'll like populate the data for you. Okay, which is nice, but the thing is you have to make sure that you type in all the numbers in order. You can't go out of order, so if you mess up somewhere, you won't get the right answer, because like, for example, 1.6 is related to 0.78, so like these were on the same day, and that's one of the criteria for matched pair. All right, so I'm gonna again kind of do some of it quickly. If you want to try it out, you're more than welcome to, but let's go ahead and do the state part. So we're gonna say let mu of D equal the mean difference of amounts of carbon monoxide and it's LA minus SF on the same day. Okay, so I'm sharing what I did. I did LA minus SF really quick. If you want to write Los Angeles, San Francisco, you can. So what's my hoe? Well, my hoe is that the difference is 0, always the same. my ha is going to be, so it says that differences have a mean equal to 0. It doesn't say less than or greater than, so my mean difference is not 0. Okay, so that's your state. Your plan part is to check everything out. Okay, so since, again, we're going to think that it's an SRS. I got this from your book, so I'm pretty sure it's an SRS. And then we're going to say n is equal to, and if you actually count these up, 1, 2, 3, 4, 16 times 2, 32. There's 32, which is greater than or equal to 30, so we're good to go. Yay, we don't have to draw it out. And this time they're actually dependent samples. And why are they dependent? Because they're from the same day. So notice, yes, they're different pictures, but this time we matched them up, so they're the same day. So every time you see dependent, think about you have to use the difference. Okay, if they're independent, you don't use the difference, you do a two-sample like 2-sample z-test or 2-sample t-test. Okay, so since this thing we're good to go, we're going to say all conditions are met. All right, so let's go ahead and we're going to do this by hand and we're going to do this by calculator. So if I do this by hand, the first thing you want to do is you want to do a 1-var stat for L3. Now, I actually didn't do all, I did it, but I'm not going to re-enter everything in. But it's really just looking at, if you typed in all your data in L1 and L2, and in L3, you're just gonna do highlight L3 and do L1 minus L2. We're gonna do a 1-var stat with just these numbers, okay? And I know this is from the first example, but again, I think you guys should be able to. So again, I'll write out the answer. So I got X bar to be 0.46, which is really D bar. So I should write this as D bar. And I got S sub D to be 0.282. So see if you get this, but this is using L3 as my list. Okay, so let's go ahead and write out the values or the formulas. So T equals, it's D bar minus your mean of D over S sub D over the square root of N. All right, so 0.46 minus 0 over 0.282 over the square root of 32. And let's go ahead and see what we get. So 0.46 divided by parentheses 2.282 divided by the square root of 32. And I got 9.227. All right, then since this is a two-tailed test, right, because it's not equal to 0, we're going to have to multiply our t value by 2, our TCDF value by 2. And since this is positive, our lower is going to be 9.227. Our upper is 1,000, and my degrees of freedom is 31. So I'm going to say this is my lower, this is my upper, and this is my degrees of freedom. I'm going to see what I get. So I'm going to get just TCDF, 9.227, 1,031. Okay, I get this answer, and again, it's a two-tailed test, so I do have to multiply it by 2, so I'm just going to go ahead and write this out. So I have 2.111 times 10 to the negative 10. Here's the biggest thing I see. Negative 10 means it's 0.00009 times before you hit this. So this is very close to 0. Okay, so if you want to think about it, I'm just writing this in. It's really approximately 0. Okay, it gets you an idea of how small this number is, because this number is not, it's not your probability, it's the whole thing that's your probability. Okay, this is if you're doing it by hand. Let's go ahead and do it by calculator. So this is your p-value if you want to make a little note. So by calculator, you are going to be using a t-test. Now, again, I don't have I'm just going to type in the data real quick. So t-test, I'm going to go ahead and you have a little thing. So if you've typed in your data, you actually can go to data and write L3 out. You have a little quick to that, but I didn't. So I'm going to do the stats part because I don't have the data written in. But if you've typed in everything, you don't actually have to do that part. So mirror 0 is 0. My X bar, and I'm just going to write out what I got. So X bar was 0.46. My S sub X was 0.282. My N was 32. And my mu is that it's not equal to mu sub 0. I'm going to go ahead and calculate, and I get T to be 9.227, which is exactly what I got, which is great. And my p-value was 2.109 times 10 to the negative 10, which is actually very close to each other, like if you think about it like that. So let's go ahead and write our sentence. So I'm going to write my sentence like over here. Okay, so I'm gonna write p-value, and it doesn't matter which one you pick because if you're doing it one way or the other. So I'm gonna do 2.111 times 10 to the negative 10, which is less than or equal to alpha. We reject ho. Okay, there is sufficient evidence that there is a mean difference in carbon monoxide in LA and SF. Okay. That is the end of chapter 9, actually. So nice job, you guys.